So let us start with internal combustion engines working. So let us come to the working of internal combustion engines. So under the classification head, we had studied that there are two types of engines, petrol engine and the next one was a diesel engine. The petrol engine was supposed to follow the constant volume cycle, and this is given known as Otto cycle. Whereas a diesel engine was supposed to undergo or follow constant pressure cycle, and this is called as diesel cycle. Now, for petrol engines, if you talk about petrol engines, they are either petrol alone as the basic fuel, or you have a combination of petrol plus CNG, or you have petrol plus LPG. These are two basic fuels. And for diesel, we have a single diesel engine. Diesel cannot run on two fuels. A vehicle running on diesel cannot accommodate two fuels. The primary reason is CNG and LPG, CNG or LPG, these they follow gas cycles. They follow gas cycles, and these gas cycles are based on Otto cycle only. So you need, with a slight modification in the engine parameters, a petrol engine can be converted into a combination of petrol and CNG or a combination of petrol and LPG. Whereas a diesel cycle or a constant pressure cycle is entirely different uh, from a petrol cycle. The basic mechanism or the basic functioning itself is different. So a diesel engine cannot be modified into a CNG or a LPG. Whereas another thing that you can ask, that if we put diesel into a petrol engine, what happens? So if diesel is used as a fuel in petrol engine, it will not run the engine. The engine itself will not run because there is a difference in ignition temperature of petrol and diesel, as well as the basic flammability of petrol and diesel. There is a huge difference, and that difference cannot be accommodated in a petrol engine. If you put petrol into a diesel engine, then the problem is, due to very less ignition temperature, pre-ignition of the petrol will take place in a diesel cycle, and which will not lead to proper functioning, and there are chances of explosion also. So the fuels, they cannot be intermixed. They cannot be run as a mixture. You cannot have a certain amount of petrol and diesel both combining together and running in a cycle. And you cannot use alternative fuels. The engine has to be specifically designed for a certain type of fuel, and that fuel makes the engine run. So you cannot manipulate the fuel while running in a cycle. So if you talk about petrol engine, let us first take a petrol engine. So petrol engine are called as SI engines. SI means, these are all classifications of petrol engine. Under the classifications only, I had told you that SI and CI engines. So SI is spark ignition. SI is spark ignition engines, and diesel engines are called as CI engines. They are compression ignition engines. So let us first see how does a petrol engine work. So working of an SI engine. If you say SI engine or a petrol engine, it is one and the same. So here what you have a piston. This is a cylinder. This is a piston. And you have a mixing device somewhere located outside the piston cylinder assembly where air and fuel is mixed in a definite proportion and it enters into it. So through this air fuel mixture, in a definite proportion, air fuel mixture in a definite proportion enters here, and the piston starts moving upward. So when the piston starts moving upward, you have, before the piston starts moving upward, this entire volume, or you say the cc of the engine, is filled up with air fuel mixture. And the piston, when it starts moving, it starts compressing the air fuel mixture or the gas present inside it. So after compression, so let us say the piston has reached here. It cannot reach the top of the cylinder because then the volume will be zero. It cannot be possible because there is some volume. It will occupy some space. So due to this compression, what happens? The temperature inside, or the temperature of the air fuel mixture, rises to a certain extent. At that moment of time, you have a spark plug being placed here. At that moment of time, a spark is being ignited here, which leads to the burning of the fuel. A spark is ignited and it leads to the burning of the fuel. Again, you can ask that why didn't we compress it to such an extent that it burnt on its own? If it burns on its own, there will be a sudden burst of energy. So, to make the combustion controllable, we increase the temperature to a range where it is just about to burn, and the final process of burning or combustion of the fuel takes place with the help of the spark plug. The spark plug delivers the difference of temperature required to burn the air fuel mixture. Now, after burning, what will happen? It leads to burning of the air fuel mixture. The petrol gets burnt in the presence of air, and due to burning, what will happen? That the gases will expand, and the expansion of the gases after burning, it leads to the piston which was initially here, it is pushed down and it reaches here. The piston is pushed down and it reaches here, and now this entire volume is filled by exhaust gases. It is filled by exhaust gases, and you have an outlet mechanism here which allows the gases to leave the system. It allows the gases to leave the system, and again fresh supply of air fuel mixture will enter into it and the process continues. Now the energy required to move the piston up is given by the engine, and this is the expansion stroke where the expansion of gases leads to the pushing of the cylinder piston from the upper end to the lower end, and this is your work output that you get. Now this work output is sent to the flywheel where it stores energy and it delivers as and when required, which also is useful in running the engine. So this is your complete cycle through which a petrol engine undergoes. So if you see here, the first process I had told you that there are four processes involved in the working of any IC engine. First is compression, second one is heat addition, third one is expansion, and the fourth one is exhaust. These four processes need to be accomplished so that an engine starts producing power. So when the piston is moving from the lower part is called as bottom dead center, BDC. BDC is bottom dead center. Why it is called as bottom dead center? Because the piston cannot go further below it. And there is a restriction that the piston will not go further below it. So this is called as a bottom dead center. This point is called as TDC. Now TDC is top dead center. Why it is called as top dead center? Because the piston further cannot go above it. This much amount of volume will be left because this much amount of volume corresponds to a certain pressure, which also corresponds to a certain temperature, which is being reached here. Okay, so you need to understand that these are the uppermost and the bottommost positions of the cylinder. So when the in the cylinder for a piston, so when the piston is moving from here to here, what actually is happening is the first process, compression, takes place. Here when the spark is ignited or the spark is applied, this is the heat addition, where heat has been added due to burning of fuel, and the burning of fuel takes place. Now after the fuels have been burned, the gases expand, and the expansion of the gases is the third process, wherein the piston is moved from the topmost position to the bottommost position. And the last one is exhaust, where exhaust gases leave the system from your silencer and they are taken out, and a fresh stock of air fuel mixture enters, which allows the cycle to be completed again and again. Okay, so this is the basic functionality of a petrol engine. Now the next is diesel engines. These are also called as compression ignition engines. So in compression ignition engines, what happens is you again have a piston and a cylinder arrangement. So, so this is the initial position of the piston inside the cylinder. This initial position is called as BDC, bottom dead center, below which the piston cannot move. Now here only air, only air is sucked into the cylinder, and this entire volume is been now filled. Let us say it is 100 cc engine, then this entire volume of 100 cc is filled with air only. Air that is sucked from the atmosphere, it passes through a filter where uh, the air is being purified of dust particles, sand particles, etc., before it enters into the cylinder, because sand particles will corrode the inner surface of the cylinder. So only air is being sucked into the cylinder, and then the piston starts moving upward. So air is compressed and the piston reaches here. This is called as your top dead center, or TDC. Now this volume now comprises of only air, which after compression has achieved a higher pressure and a temperature. Now the compression or the amount of compression that takes place in the case of diesel engine is more than the case of a petrol engine. Diesel, air is compressed to a larger extent. The compression ratio, if you say, the compression ratio is around 8 to 12 in the case of mm, SI engines. That means mm, it is compressed to 8 to 12 times of the initial pressure. Similarly, here it is around 20 to 25. So it is compressed to 20 to 25 times. That means this volume which is left over will be small as compared to a petrol engine. The diesel engine, this volume will be less. So on this high temperature and pressure air, you have injectors here. These are injectors. Injectors are used to spray diesel on the high temperature air. Injectors are used to spray diesel on this. So due to the spraying of diesel, what will happen that when diesel is being sprayed on a hot air, it leads to the burning of fuel. So this burning of fuel. What will happen? On hot air, you are actually spraying diesel, and this diesel is burning. This is heat addition. After heat addition, what happens? The gases will expand, and this was your initial position of your piston at the time of burning. And the expansion of gases, it pushes the uh, piston from topmost position to its bottommost position. Okay, and now this is entirely filled with exhaust gases, and here exhaust takes place, and the exhaust gases are removed from the system, and the entire cycle is complete. Again, in the next cycle, fresh air stock will enter into the cylinder, it will get compressed, diesel will be sprayed onto it, and it will lead to the burning of the diesel. The burning of the diesel will expand the gases, and the expansion of gases will push the piston from its top dead center to the bottom dead center. This pushing of the piston from TDC to BDC is your power stroke, and this power will be utilized to run the vehicle. Okay, now again I had told you that this is a constant pressure cycle. It is a constant pressure cycle. So here what happens that when the piston is at this position, it is filled up with high temperature, high pressure air. Okay. Now when diesel is being sprayed onto it, if the volume remains constant, if the volume remains constant and diesel is being sprayed on it, the pressure in this part will increase because you have a limited amount of volume and more matter is being inserted into it. So when the diesel spray takes place, the piston moves down. The piston moves down by a very small amount so as to keep the pressure constant. The piston moves down to a very small amount so as to keep the pressure constant. Therefore, or this is the reason why it is called as a constant pressure cycle. In the case of a petrol engine, this position of the piston was constant at the time when burning takes place. Whereas in the case of diesel engine, the position of this piston is exactly not constant. It moves down or it increases the volume by a small amount at the time of diesel being sprayed on into the cylinder. So this is how it is called as a constant pressure cycle, and that is called as a constant diesel cycle. Now, two-stroke and four-stroke engines, they can be petrol engine or they can be diesel engine. Now, why are they called as two-stroke and four-stroke engines? So, before I start with it, you can see that there are four basic processes. First one is compression. Second one is heat addition. Third one is expansion. And the fourth one is exhaust. Now, these four have to take place. They have to undergo and they have to take place in this order only so that one cycle is completed. So, in a two-stroke engine, what happens? That this is a piston. Sorry, this is a cylinder and you have a piston here. Now, you have a port here. This is called as a port. Port means this is an opening. This is called as an inlet port. Through the inlet port, air fuel mixture enters, and as the entry takes place, the piston starts moving upward. The piston reaches its final position here. So this is one one stroke means one stroke is the movement of the piston from the BDC to TDC. So BDC, this is your first stroke, stroke number one. So in stroke number one, the piston moves from BDC to TDC, thereby compressing the air fuel mixture. If it is a petrol engine, if it is a diesel engine, it will compress the uh, air. It will compress the air to this extent. So whatever the engine is, the process for a two-stroke or the working principle for a two-stroke engine is same. That the piston has moved from BDC to TDC, either compressing the air fuel mixture or compressing the air, whatever it is, depending upon the cycle, whether it is a petrol engine or a diesel engine. This is your one stroke. Here, heat addition takes place, and this in this heat addition, what happens? That either a spark is been initiated, so to burn the air fuel mixture, or you have diesel being sprayed onto it, so that the fuel it burns, and the burning of the fuel leads to the production of heat addition. That is heat addition. After heat addition has taken place, this is your second stroke. So in the second stroke, what happens? This is your initial position of the piston. This is your initial position of the piston. This has this is in this position after heat addition has taken place, and after heat addition, what will happen? The gases will expand, and it will push the piston from TDC to BDC, this location. So this is your BDC. It has been pushed. This is your expansion, and this expansion has been done. And again, you have an outlet port here, and you have an inlet port here. So from the outlet port, the exhaust gases they leave. The exhaust gases leave the system, and simultaneously, fresh gases enter into the system. So what happens? One movement of the piston is the energy required to run this system is one motion of the piston is being given by you, and while it comes down, the piston gives us back energy which is used to run the vehicle, as well as supply energy to this piston to again perform compression. So this is a two-stroke engine. Two-stroke engines means one upward and movement motion of the piston inside the cylinder. A two-stroke system means one upward and downward movement of the piston inside the cylinder. In the case of two-stroke engines, you have two ports, inlet port and outlet port. So in the through the inlet port, air fuel mixture or air, whatever is applicable, enters into the cylinder. Through the outlet port, exhaust gases leave the system. If you see the system, both the ports are at the same time open. So what will happen? There is a possibility that some amount of unburnt air fuel mixture leaves through the exhaust port. Okay. There is also a possibility that some amount of exhaust gases they stay back into the system and they are further compressed. Okay. It is wastage of energy. So in a two-stroke engine, you have high power output, and the fuel efficiency is poor because some fuel is lost. It goes through the exhaust port. Fuel efficiency is poor. The power produced is more. The why the power produced is more, that will be clear after you understand a four-stroke engine. Okay, and you have higher fuel efficiency in the case of a four-stroke engine, not in the case of two-stroke engine. So first, let us see the working of both two-stroke and four-stroke engines, and then we'll compare them in our next cycle. So now come to a four-stroke engine. In a four-stroke engine, what happens? This is four strokes are carried out. So here what happens? This is the initial position of the piston. You have two valves here. These are valves. There is a difference between valves and ports. A valve is a mechanical mechanism by which you can control its opening and closing, whereas a port is always open. So valves, this is an inlet valve and this is an outlet valve. So in the first process, obviously again you have compression. In the compression stage, what happens? Outlet valve is closed and only air, in the case of diesel engine, and if it is a petrol engine, air fuel mixture means petrol and air and petrol, they are injected into the chamber. Let us say if the chamber is of 100 cc, this 100 cc is filled with petrol air fuel mixture or air only, depending upon the cycle they are following. The outlet valve is completely closed. So the outlet valve is completely closed. After it has been filled by air fuel mixture, the piston starts moving upward. When the piston starts moving upward means from from this position to this position, you have again these two walls. Both the walls are closed. Here this is closed, this is open. So both the walls are closed and the compression takes place. That means air fuel mixture or air is compressed fully with both these walls being closed. Now, either a spark at this moment of time, either a spark or diesel is being sprayed depending upon the cycle that it is following, which leads to the burning. So this is your first compression. This is your heat addition. Now third, what happens? After this burning takes place, while here the burning is been taking place and both the valves are closed, inlet and outlet valves are closed, and either diesel is been burnt here or air fuel mixture is been burnt here. Now again both these valves are closed and and the piston moves down. The piston is moving from, in the first process the piston is moving up, the second process piston is moving down. Yes sir, this is not moving down, it is constant here. In the third process, what happens? The piston is moving down, and when it is moving down, again both the processes are closed, and the third process, expansion, takes place. Expansion is taking place, and the piston is moving downwards, and complete expansion takes place. After this, what happens? This is your position of the piston, and this valve is closed, inlet valve is closed and outlet valve is open. This entire volume is being filled by exhaust gases and the piston starts moving upward. So when the piston starts moving upwards, it forces all the exhaust gases out of the system. It forces all the exhaust gases out of the system, which leaves the outlet port, and this entire volume is free of any exhaust gases. Once it is free of any exhaust gases, the piston is here. The piston starts moving down. When the piston starts moving down, at that same moment, the inlet valve is again open and it allows a fresh stock of air fuel mixture to enter into the cylinder or air to enter into the cylinder, thereby initiating either the diesel cycle or the petrol cycle. So this is the working of a four-stroke engine. So again, if you go through it very fast, this is an inlet port is open. Sorry, inlet valve is open. These are two valves. So the opening and closing of the valves is controlled with the another mechanism which is present inside the engine. So the inlet valve is open. This is filled with air fuel mixture or air, whatever it is. Then it is compressed. So after compression, what happens? This is compression process being taking place. In compression process, again, after compression, this entire volume, both the valves are closed and you either supply spark or diesel onto it. It leads to heat addition. After heat addition, the gases will expand, the piston goes down. At that time also, both the valves are closed. It is expansion, which is called as power stroke that you get out of it. And again, the piston moves up, taking or completely removing the exhaust gases from the cylinder, and a fresh torque when the piston starts coming down, a fresh torque of air fuel mixture or air, whatever is applicable, comes enters into the inlet port, inlet valve. So here you have valves which the opening and closing is controlled, and it allows the air fuel mixture or air to enter into the cylinder. Here you can see that complete combustion takes place, complete exhaust takes place because the entire exhaust has been removed. There is no possibility of mixing of the fresh torque as well as the exhaust torque inside the cylinder. Here you can see that the entire process has taken place in two movement of the piston. First the piston was here, so piston goes up, one, piston goes down. So this is one two stroke. एक बार ऊपर जाना, एक बार नीचे जाना, इस टू स्ट्रोक, और फिर ऊपर जाना ताकि गैसेस बाहर निकाल सके, और फिर नीचे आना इज अनदर स्ट्रोक. So you have four movements of the piston. In the case of two stroke, you have two movements of the piston. One is one, the power for one is given by you, and the power for the other is given by the engine. Here you have four motions of the piston. One power for three is given by you, and you have only one power stroke. The only advantage of a power, if you compare these two engines, a two-stroke engine has a greater power because you are investing less. Here you are investing more. But the advantage of a four-stroke engine is it is fuel efficient. There is complete burning of the fuel, complete expansion of the fuel, complete exhaust of the fuel. So the fuel efficiency is more as compared to a two-stroke engine. This is the reason why there are two-stroke engines throughout the world are been replaced by its four-stroke counterparts, because mm, smoke inside the two-stroke engine, it consists of nitrous oxides due to the presence of unburnt fuel molecules. So this is about four-stroke engines.